We have permanent magnet and Faraday's experiment with permanent magnet over wire, which changes the direction of the current, brought us to idea that that magnetic field is spinning actually. This can be illustrated by glass filled with neon gas and with a little exciter, the electronic exciter which lights that plasma, gas plasma, and that helps us to illustrate or show that rotating tendency or spinning tendency of permanent magnet field. Now, we have North Pole in proximity of the wall. It shows tendency to spin to the right in accordance with right-hand rule. Now, if we put same polarity the inside of the glass, it will be different story because field lines are returning, and we are actually indicating the outer character of the field, which rotates opposite way. It means when we put it inside, it should rotate counterclockwise. As we see, the tendency is to rotate this counterclockwise, and it eventually excites all plasma in all glass in spontaneous rotation. Now, when we put South Pole to the glass, it shows tendency to turn plasma to the left side, means counterclockwise. It means that when we put it inside, it will turn plasma clockwise, the opposite way, because we are indicating outer field of the magnetic line. You see the tendency to right. And again, if we go inside, it is spontaneously rotating all neon plasma. Now, another interesting experiment is that when we put small magnet, there are 3 small magnets, inside in a glass with the South Pole aiming upwards. So if we use South Pole from the other side, we see that it is rotating faster. It is actually amplifying the South Pole. So we have clockwise rotation, quite intensive, because it is between 2 South Poles. It's like those magnets are repulsing to each other. So we can also slow down that we see the plasma rotating. We see clearly that it turns clockwise. So that's about this. So again, South Pole tends to turn plasma to the left side, and North Pole tends to turn the plasma to the right side, clockwise. But when we indicate outer field of returning the magnetic lines, if we see opposite rotation. It shows that the magnetic lines are actually, they have spin while they are exiting and entering magnetic pole.